This is the second section on portfolio optimization. So this is Sharpe Ratio, which is going to be a statistic that we use that combines information on the additional risk and the additional return that we get when we move from one investment to another. Or if or maybe not even moving from one to another, but we can compare investments using the Sharpe Ratio. So let's just assume we have a two-stock portfolio. Stock A has a return of 5%, standard deviation of 10%. Stock B has a return of 6%, standard deviation of 13%, and the correlation is 0.4. This is the same thing we saw earlier in the minimum variance portfolio example. If we assume equal weights, so we put equal 50% in A, 50% in B, the return is just going to be the average of the 5 and the 6%, so we're going to get 5.5%. So half, this is the weight multiplied by the return for A. This is the weight, 0.5, multiplied by the return for B. If you average the 5 and the 6, we get 5.5%. And the standard deviation, this is the share A squared times standard deviation of A, share B squared times the standard deviation of B, plus 2 times the share A, share B, times the correlation, times the standard deviation of A, times the standard deviation of B, gives us 9.66%. So we see a little bit of benefit here from investing in both A and B. So we get a return that's slightly higher than A, and we get a standard deviation that's lower than A. So we're not doing quite as well as the return here, but notice our standard deviation is lower than this one right here. So we get a standard deviation of the portfolio that's lower than the least risky stock in the portfolio. And that's what I'm calling the benefit of diversification. Now we're going to switch it up a little bit, and we're going to invest in a stock, which is something that has risk, and a bond which has no risk. And notice we are measuring the no risk as a 0% standard deviation. So if you have something that does not vary, the correlation between something that doesn't vary and the thing that does is always going to be 0. So if you look at the covariance or correlation between a stock and a bond, when the bond has no standard deviation, that correlation is going to be 0. And this simplifies our problem quite a bit because when we're calculating the variance of a portfolio with a bond, it's just the share of the risky thing, WA, times the standard deviation of the risky thing. So in this case, it's 5%. So since we have half of our portfolio in the stock, this standard deviation of the portfolio is just half the standard deviation of the stock. So notice this 5% is exactly half of the 10%, and that's because we have half the portfolio in stock A, and there's no correlation between this bond and the stock. So that big long formula that we had right here, where we have the share A, or the share A squared times the variance of A, share B squared times the variance of B, and then all these covariance terms, this is 0 because the share B is 0.5 squared, but the standard deviation of the bond was 0, so this term goes away. But we're also assuming there's no correlation, so all this term goes away as well. So all we're left with is the share A multiplied by the standard deviation of A, and that's how we get that. That's why it simplifies to this nice, neat little formula right here. And the return on the portfolio with the bond and the stock is 3%. So notice our return is significantly lower than it was before because we're investing half of our money in a portfolio, or half the money in our portfolio is in something that's only earning 1% compared to earning 5 and 6% before. So the standard deviation is also quite a bit lower. So our standard deviation before was 9.66%, where now the standard deviation is 5%. So if the standard deviation goes down and the return goes down, that might be optimal for a particular investor, depending on their risk tolerance. If the risk goes up and the standard deviation goes up, that may also be better for a particular investor. Now, if the standard deviation goes up and the return goes down, that's clearly not in the investor's best interest. And that's what we're thinking about with the minimum variance portfolio and the efficient frontier, where we can see if we eliminate those portfolios below the minimum variance, we're on that upper portion of the efficient frontier. If the return's going up, so is the risk. If the risk is going down, so is the return. So when we're thinking about risk and return with risk-free assets, this is where we start thinking about the slope of the line that connects the bond to a stock. So if we're thinking about all the different options we have right here. So here we did 50-50. So we have A, 5% return, 10% standard deviation. Bond, again, 1% return, 0% standard deviation. If you look at this chart, what we're really doing here is looking at the combinations of the bond and the stock. So if all of our money's in the bond, we get the bond return with no standard deviation. If all of our money is in the stock, we get the stock return and the stock standard deviation. We can also choose any combination of the stock and the bond. So if we put 10% in the stock and 90% in the bond, notice our return goes up because we're now averaging the stock return with the bond return. So it's a weighted average of the 10% stock, 90% bond with the 5% return on the stock and then the 1% return on the bond. And notice as we keep moving down here, as we increase the share of A, we're actually moving up this line right here. So as we increase the share that we have in the stock, the return goes up, but so does the risk. And that's the trade-off that we have to face. So we're not able to increase our return at the same time we reduce our risk. That would be a free lunch, and everyone would choose the highest return, lowest risk option. And we know that doesn't exist. So when we're thinking about the trade-off here between risk and return, what we're really thinking about is the slope of the line that connects a bond to something that's risky. And this can be a portfolio right here. So this could be a single stock that has a return of 5% and a standard deviation of 10, but that could also represent a portfolio that has a return of 5% and a standard deviation of 10%. But all that really matters here is we're connecting something that's risk-free to something that is risky. So if we're thinking about the Sharpe ratio, and that's where we're headed, it's the slope of a line. Just like beta was the slope of a line, this is the slope of a different line. So they're completely different concepts, but they're both go back to this very fundamental mathematical concept of slope. So RS is the return on the stock, RB is the return on the bond, SS is the standard deviation of the stock, SB is the standard deviation of the bond. But we know this is zero because the bond has zero standard deviation. So if you're thinking about RS minus RB, you could come up here to this point. Any point on this line would be some combination that you could have, but we're going to think about up here on the stock, and at this point here that's all stock, and then this point down here represents the bond, and the slope of that line is just the additional, actually let's do it right here, the slope of this is just the additional return you get from investing in the bond. So if you think about this, it's the rise part right here. So in this case, if you went all stock, you would have a 5% return, which is 4 percentage points better than the all bond. So the 5% minus the 1%, that would be the numerator. And then the slope, the denominator here, is the standard deviation of the portfolio. So that's the additional risk you had to take to get that extra return. So the numerator is how much return you get above and beyond the bond. The S is how much risk you had to take on to get it. So this is the benefit, this is the cost. So that Sharpe ratio considers both the additional return you get and the risk you had to take on to get it. And that is what we call the Sharpe ratio. And you want the biggest number possible. So the higher the Sharpe ratio, the better that trade-off is between the risk and the return. So notice with the Sharpe ratio, the numerator could get larger, you could get an even higher return, but if that denominator is increasing fast enough, it might not be worth it. So that at some point, that extra risk may not be worth the extra return, or that extra return that you're getting might not be enough to compensate you for that extra risk that you're taking. So if we're comparing a couple different options here, A, B, C, and D all represent stocks or portfolios, but all that matters is they have a return and a standard deviation. So if we're looking at A, it's a standard deviation of 4%, return of 3%. So that's this point right here. B is this point out here, a standard deviation of 10% and a return of 6%. Point C is the 8% standard deviation, 3% return, and then D is the 6% standard deviation, 5% return. So we want the one with the steepest slope, and when you plot these, it's really obvious to see that D is the best option. D is the fund that gives the high Sharpe ratio, because that's the steepest slope. But let's think about how we actually calculate the Sharpe ratio. Again, we're assuming the risk-free rate is 1%. So if we take the return of 3% and we subtract the risk-free rate, that risk premium would be 2%. 2% divided by 4% gives us this 0.5. So the 2 divided by 4 is the 0.5. And notice that A and B, even though they have different returns and different standard deviations, they have the same Sharpe ratio. So an investor would be indifferent between A and B. In fact, they probably would ignore A and take B, because we can always get A by weighting B with the bond. So if you go back here and look at this line, we can get any combination that we want along this line by just choosing different weights for the stock and the bond. In this example, we could get option A by weighting B with the bond. So option A can actually be replicated with combining B in the bond. Option D, the return there is 5%, so subtract the risk-free rate. That would be 5 minus 1 would be 4. 4 divided by 6 gives us the 0.67. So that gives us the high Sharpe ratio. And even though C, notice the return's the same as A, but notice how much higher the standard deviation is. And that's why we get this lower, this flatter slope. So if you just want to visualize a Sharpe ratio, you can always just go on just this XY plane where your standard deviations in your horizontal axis, returns on your vertical axis, plot them, and then calculate the slope of the line that connects the two points. It will always anchor down here with the bond, 0 standard deviation and that return. So in this case, it's 1%. So the tangency portfolio is the portfolio that connects the risk-free rate to the tangency portfolio, to the efficient frontier with the high Sharpe ratio. So we can try all the different combinations starting at the red dot and moving up the efficient frontier, and we can choose the one that has the maximum Sharpe ratio. So think about this. Think about connecting the risk-free rate right here. Let me just get a marker. This never works well, but we'll try. If I connect that to the minimum variance right there, that is the slope of that line is the Sharpe ratio for the minimum variance portfolio. But notice this up here, it actually does better than that. So anything that connects the risk-free rate to the efficient frontier that has a steeper slope than the minimum variance dominates the minimum variance. So we notice that's even better. But if we think about, well, why not choose this one way up here that has the highest return? Notice the slope of that red line that I connected is actually flatter than this one right here for the maximum Sharpe ratio. So the tangency portfolio is that point on the efficient frontier that gives us the maximum Sharpe ratio. And the way I like to think about this is, let's just start here. I'm just going to raise this up. And I'm going to tilt this over until it just touches the frontier. So as I keep dragging this over, that's the point where it is tangent to the efficient frontier. Tangent means it has the same slope as that point on the frontier. So it touches it at only that point, and that's how we visually determine what the tangency portfolio actually is. So once we have all of those infinite combinations of stock A, stock B, stock C, we eliminate everything, or in this case, it's just, I think we had 2 stocks. We eliminate all those other options that have a lower return for the same level of risk. There's one particular point that gives us the maximum Sharpe ratio. So there is one optimal portfolio for a given risk-free rate. Now, what happens if the risk-free rate were to increase? So let's say instead of the risk-free rate being down here in this example of 0.25%, what if it was at 1%? So what if we actually started right here? And now we tilt it over until we get to that efficient frontier. Notice that we're now somewhere up here for our tangency portfolio. So that tangency portfolio is going to depend on the risk-free rate. The higher the risk-free rate is, the higher and to the right on the efficient frontier, you'll find the tangency portfolio. Because if you can get a higher return risk-free, that frees you up to put a little bit more of your money in something that has a little bit more risk. So all we're thinking about the tangency portfolio, it's the one on there that has the highest Sharpe ratio. It will always be on the efficient frontier. And now the investor can choose any portfolio on the tangency line. So we can now ignore every single point that's not on the line that connects the risk-free rate with this blue dot right here for the tangency portfolio. We're not going to go above it because those portfolios have a lower Sharpe ratio. We're not going to go below it because those have a lower Sharpe ratio. So the only thing that's relevant right now would be the portfolios that fall just on that line right there. This dark line right now represents the different combinations of return and standard deviation that the investor can choose. And the cool thing about that is they're now able to invest or choose things that are no longer on the frontier. They can now choose something down here because they're mixing it with a bond that has a lower variance or lower standard deviation than the minimum variance portfolio. But just think about this right here. If you look at this minimum variance portfolio and we go up, notice this point right here has a higher return and the same level of risk as the minimum variance portfolio. So this is why I said in the previous section, the minimum variance portfolio is very, very rarely, it maybe never, the optimal portfolio if you can combine the risky stuff with the bond. So all we're doing with the tangency line is connecting the risk-free asset with the portfolio with the high Sharpe ratio. So we need to think about, I'll go through examples with this in Excel because there's math behind this we haven't seen yet. What we're finding in this example is stock 1 gets 52%, stock B gets 48%. That represents the blue dot. So that tells us where we're falling on the efficient frontier right here. The return was 1.96% and a standard deviation of 2.73%. Again, that is, again, from the blue dot. So our return's just under 2% and our standard deviation is just under 3%, which is exactly what we're seeing right here. So now the question we have to answer is how do we allocate our money if we want to target a certain level of risk? So I'm calling R bar, I'm sorry, I'm still drawing lines here. I'm calling R bar the desired level of risk. So that's what we're calling the desired level of risk. How much do we invest in the portfolio? How much do we invest in the bonds? So what we're thinking here is this, let's just call this 2%. So if the tangency portfolio has a return of 2%, the bond has a return of 0.25%, this investor can choose any return they want between 2 and 0.25 as long as it's on this segment that connects the tangible portfolio to the bond. So if they want a 1% return, they can come over. Well, they have to accept whatever level of risk comes with that 1% return. So let's say they want 1% return. That means they have to accept this amount of risk. So how do we determine the weight of A and the weight risky and the weight for the bond to get that desired level of return? We could also work it this way. The math's a little more complicated, but we can do it. They can set a desired level of risk. Let's say they're okay with the standard deviation of 1.5%. We go up. That's the return that they can get for a 1.5% or 1.5% standard deviation. So what we're doing is just solving this simple inequality right here, or this simple equation right here. So if we go back for how we determine the return on a portfolio, remember it's just the weighted average of the bond return and the stock return, but we can also we can target a certain. I'm sorry. Our bar is the desired level of risk, not the desired return. I said that in the opposite way earlier. Our bar is their desired level of risk. So what we're really doing, we are going the way I mentioned earlier. We're starting right here and going up. So once they choose their level of risk, how do we determine the return and how much we should actually put there? So remember that the standard deviation of a portfolio with a bond is share risky times the standard deviation of the risky thing. Well, if we have the share risky, 1 minus that has to be the share for the bond. So this is just a way of rewriting what we saw all the way back here. We're just rewriting this, where the weight for the risky is just 1 minus the share for the bond. So we rewrite that and solve this for W bond. And when you do that, we get the share bond is just 1 minus the desired level of risk, 1 minus the ratio of the desired level of risk divided by the standard deviation of the portfolio. Which means R bar divided by the standard deviation is invested in the portfolio, and then the rest of that is going to be invested in the bond. And there is some intuition there. It's a little harder to see without actual numbers, but let's say they desire a standard deviation of 1%. So 1% divided by 2.73%, 1 minus that, 0.63, that's how much they're going to put in bonds. And they're going to put their remaining portion. Okay, and they're going to put some in stock 1, some in stock 2. So the sum of these two numbers right here, stock 1, stock 2, they have to add up, plus this have to add up to 1. So once we know how much is going in the risky stuff, then we have to allocate the risky stuff among the things in the actual portfolio. So all we're determining right here is how much goes in the bond, how much goes in the portfolio, and then we have to use the weights that we find right here, the 0.52 and the 0.48, to determine how much goes in stock 1 and stock 2. And that's going to make a lot more sense when we actually do this in Excel. So I'm not even going to try to wiggle through the math here in the intuition. We'll do all of this when we look at these problems in Excel. Again, the return is just going to be the weighted average of the bond times the share bond, and the standard deviation of the tangency portfolio, the return on the tangency portfolio multiplied by the weight in the tangency portfolio. So notice that 0.37 is what you get if you add up the 0.19 and the 0.18. So all we're doing right here, is showing you where this investor actually falls. So here's the bond right here. Here's the portfolio that maximizes the Sharpe ratio. So this is the tangency portfolio right here. This person chose a portfolio with a standard deviation of 1%, and this is the return that they got. So for this investor, this black dot represents the portfolio that satisfied their desired level of risk. Again, they can choose any desired level, any level of risk between 0 and whatever. What did we get here? 2.76%? 2.73%? Yeah, 2.73%. So they can choose all their money in the standard portfolio. They get this return and this standard deviation. They can choose the bond and get a return of 0.25% with no risk, or they can choose any combination that connects those two things together. And when we do this in Excel, I promise it will make a lot more sense. It's a lot of buttons to get to one fairly simple answer, but all we're doing here is looking at all the different combinations of stock A, stock B, the bond, and trying to figure out which one gives us the desired level of risk that the investor actually wants, is comfortable with.